Okay, so our topic is on natural disaster prediction using artificial intelligence. So I'm going to talk about the background of the problem. So there have been increasing weather-related disasters in the past 20 years, and then also increasing damage like deaths and economic losses. So some examples of natural disasters include tropical cyclones. There are also increase in hot extremes, heavy precipitation, and droughts. For example, there have been increasing heavy precipitation and hot extreme events globally and increasing droughts in certain areas or regions.
So let's move on to the next section, which is about the current existing technology. In this part, we will explore current technology to predict the natural disaster. So normal weather forecast can be predicted decently at most 7 days with around 80 to 90% accuracy. This forecasting can be predicted at best 10 days, but it's still like pretty decent accuracy. So efficiency is going to be nearly as the same as the weather forecast. The floods can be predicted 1.5 days with around 90% accuracy. And also the wildfire as well, around a day in advance with 90% accuracies. But the limitation of this kind of disaster is that they can only tell the type and the location, but there's no detail or the magnitude or the severity of the prediction.
And so next off, we will be talking about the goals we want to achieve in our project. The first goal is that we want to make better weather prediction with artificial intelligence. And here, this graph is a prediction of today's precipitation that we made 10 days ago. And if you look outside of the window, it's pretty sunny today, which means that our predictions are right. But then the more important part of our project is the second goal. That is, we want to predict disasters like flood, typhoon, or drought, instead of only predicting atmospheric variables like temperature, humidity, or wind speed. Why is that so? It's a graph of precipitation, but you can't infer much from it. But then, if we want to truly predict the disaster type, then this would be useful because it can be readily used by the government to take action instead of atmospheric variables, which is pretty much an intermediate result. For example, the expected loss of life, the expected injuries, as well as the expected economic loss to better characterize what kind of disaster this might be. And this is our overall proposed pipeline. First, we collect the atmospheric variables now, then we feed it into a large pre-trained foundational models that try to predict variables in a certain time in the future. Then we train a linear classifier to predict the type of disasters as well as other relevant information. These days, AI is all about big data, and we have plenty of big data online. The first data we're going to use is the ERA data, which is a historic recollection of atmospheric variables. And the second data space is much more interesting. It's a data of past disaster information. If we can find the correlation using a simple multi-layer perceptron classifier, which is a very common AI technique these days, then we can incorporate this classifier back into our pipeline. And then here we are. We have a complete pipeline that's able to predict disasters.
I'll talk about the expected social impact. And as it's known, though we cannot control these natural disasters, we have the power to mitigate their impact through accurate forecasting. When a hurricane struck Galveston in Texas in 1900, over 8,000 people were killed. But by contrast, Hurricane Hugo illustrates the benefits of an effective prediction system. Without a successful prediction, the Hurricane Hugo the loss of life could have reached thousands. But the actual death number was only 67. And you can see that Hurricane Hugo is also very powerful. And for a sudden disaster like an earthquake, preparation system is also very useful. They have the similar intensity, but Japan managed to save thousands of lives. And so it's very urgent to have a universal prediction system, and an AI prediction system definitely has the capability to do that. Training the model with sufficient data, and AI model can be both easy to use and very low cost, making it accessible to a wide range of regions and communities.
We would like to talk about the most important part of our presentation, and that is how we can take a preemptive strike to climate change disasters by better mitigation with better early precautions. Just a case study. We all know the Typhoon Mangkhut that have wrecked Hong Kong recent years. The situation back then was that we didn't realize that the damage would be so extensive, and we are pretty much unprepared for it. The people who are responsible for the recovery after the disaster are only called emergently after the typhoon have struck Hong Kong, and that resulted in a lot of problems after the typhoon. But if we have a better prediction, such as those that we have proposed, then the government could have called in these people earlier and made sufficient preparation with enough resources so that the damage towards people and the places can be minimized. And with that, I'd like to wrap up our presentation, and I'd like to thank you all. Thank you.
Before Mangut struck Hong Kong, we have never had a case as severe as the impact of Typhoon Mangut. 60,000 trees were broken and fell and so on. So without those historical data, how can you predict the impact of certain kind of natural disasters?
I think it's not only about historical data, because of course in Hong Kong we don't have these kind of typhoon, but then in other places in the world there are similar types of typhoon. For example, Katrina that hits US. We are looking at the atmospheric variables. If we train a model, it will learn from the data, the disasters all around the world, and it can draw that knowledge back and to apply it to, let's say, Hong Kong, so that even if we don't have the historical data locally, because our model is quite global, we train on global data, we can still account for this situation.
When typhoon comes, that's not only a problem of wind, but it also the problem of flooding or damaging of houses. So how you are able to calculate or predict these complicated effects?
Why we want to train on large data, big data all around the world that has a lot of entries, because the one thing very powerful about AI today is that it can uncover some hidden trends, and they can learn from these hidden trends. Of course, I wouldn't say that they are like all powerful, they can learn all these hidden trends, and of course I wouldn't say that they are completely accurate or so, but then it will provide us with some very interesting insights, as well as in today's world a better accuracy than what we have now.
How would your model to deal with the state of the built environment of a particular place in dealing with the same level or same type of disaster?
We will also incorporate geographical data, which is we haven't incorporated now, but we'll incorporate later into the variables. And then we can make use of these variables to predict whether a particular place will be affected by the disaster. We are to predict flooding or landslide. Maybe the place with a steeper slope can have vulnerable to these disasters.
What kind of fallback scenario you have built into your sort of model?
So the first part is technically how can we improve the accuracy of our model so that this does not happen. One of the ways we were not doing it, but just to explore the possibility, we could train multiple models and then use ensemble learning. Then the kind of error will be minimized. And another way is to also predict the error of the prediction. It's like, because now we're only predicting the values, but if we can also predict the error of the value, then we can also predict how reliable that kind of prediction is. And that would perhaps address part of your question. But then the most important part is AI could never be 100% correct, and that is something that is we all have to bear in mind. And I won't say it can be solved, but it can be addressed by education. Because, well, let's just go back to a very simple example. Today, maybe the HK Observatory make a prediction saying today is rainy, but then it turns out that it's sunny. And then some of the people will start to get a little annoyed saying, oh, they predicted wrong, or how come it's like that? But then we all know that there can be errors in prediction, and we are all educated enough to know that and really accept that having a prediction is better than not having a prediction. And I think it has a lot to do with education in AI towards the general public, to clearly illustrate to them that with AI, the prediction is actually more accurate than what we have now. If we can educate them in this way that having AI is better than not having AI, and that it will be better that you are evacuated and nothing happens than you are not evacuated and are heavily affected by the disasters. And over time, I think the public will have more understanding on this aspect.
Thank you. Thank you.